Hello, Riles. Let's look at lesson 4.5 on more related rates. I want to do another approach to example 2. It's not going to work out as nice, but I just want to make it clear that you have options here. So we have a cone. I've sketched that. I have developed a formula for the volume of the cone. It is 1/3 of the volume of a prism. The volume of the prism is the area of the base multiplied by the vertical height. I take 1/3 of that. And in the question, I'm given that the water is draining at a rate of 2.5 milliliters per second. Now, on a quiz or on a test, maybe I would just say I would change that to cubic centimeters per second. 1 milliliter of water is cubic centimeter of water. It's draining, so it's very important that I get the negative here. Otherwise, my sign on my dH by dt is going to be wrong. I'm given dV by dt is negative 2.5. I am asked to find how fast the water level is dropping. That's a rate of change of height with respect to time. And then I'm given an instant, and this instant is reported in a number of different ways. It says when t is equal to 30, h is equal to 10, and r is equal to 4. So I have no other information about this cone, so the only information that I can draw is the information from that instant. And I want to be very careful about maybe substituting in that information too early, but it's all that I have right now. Oops, there's my height, there's my radius, and here's the instant, 10 and 4. And what the lesson pointed out is that in this case, if you draw another instant, you'll see that you have similar triangles. So the ratio of radius to height has to be constant in this application. So you're not using the instant values before you differentiate. You're using the mathematical relationship to relate your variables, just like how we use the Pythagorean relationship in the ladder problem to relate our variables. Okay. What I want to try doing today, though, is maybe not relating my variables, maybe taking a look at using a chain rule, not building my chain first, but using a chain rule and then seeing what I'm responsible to find. So after I declare my variables, I'll say let V, I'm going to need R, H, and I'm going to need T. Represent, let's see, the volume, radius, height. I guess all of these, the volume, the radius, and the height are of the water. Not of the cone itself. You could say of the cone of water. And time. And again, I'll just declare the volume in cubic centimeters, 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 and seconds. Okay. So from my relationship between my variables, I am going to jump right into differentiating with respect to time. Maybe not a great idea, but I don't see too many problems with it right now. I know how to use the chain rule. Does that mean that I should use the chain rule? Yeah. All right, I also know how to use constant multiple rule, so why don't we call this pi thirds of, I'll get dv by dt over here. Notice dv by dt is known in this case, but that doesn't concern me. I don't need my unknown to be isolated here. I can always rearrange and solve later. Constant multiple, and then I have a product, so I'm using the product rule. I'll do the derivative of the first. To take the derivative of r squared with respect to time, I take the derivative of r squared with respect to r, multiplied by the derivative of r with respect to time. There's the second, plus the first, multiplied by the derivative of h with respect to h is 1. I chain that with the derivative of h with respect to t. Okay. So here's my disadvantage that I notice pretty quickly, I suppose, is that by taking this approach as opposed to how I related my variables first in the printed lesson, I now have more quantities. And when I take my inventory, and I strongly encourage you to do this if you find it helpful, this is known. At the instant, I know h and r, so that's known, and that's known, and that's known. All of those are known or given. I'm looking for dh by dt. So I want that. So here's the problem, is that it looks like I need dr by dt. But dr by dt sounds like the same type of unknown quantity as dh by dt. Like if I knew how quickly the radius was changing with respect to time, wouldn't I know how quickly the height is changing with respect to time? So here's where this approach feels a little bit backwards. What I feel like I need to do now is maybe not find the value for dr by dt, but find an expression. I don't need the number. These are known values. I need some sort of expression for dr by dt in terms of these other knowns. So I cannot avoid relating these quantities. And I would argue that maybe we should just do that first. Waiting until later to do that doesn't seem like a great approach. Let's see, I know the ratio of r to h is going to be 4 to 10 at all times in this triangle. Since I'm trying to find dr by dt, this one time I think I'll isolate. I'll get r is going to be 2/5 of h. Now I could actually substitute in every instance of r with 2/5 of h now. I don't think it's a great strategy because, like I said, I already know what r and h are. It's just this expression that I need. And I discover, maybe it's not surprising, that if the radius is going to be 2/5 of the height, then the rate of change of the radius with respect to time is going to be 2/5 of the rate of change of the height with respect to time. So now I know an expression for dr by dt in terms of dh by dt, which is what I want. It's another unknown quantity, but it's the unknown quantity that I'm trying to solve for. Okay. Excuse me. Now let's substitute in all known quantities into all other expressions. Sub all knowns. And we will get dh by dt we were given is negative 2.5. There's pi and there's 3. 2, the radius is 4. dr by dt, I'm going to substitute in or replace that with 2/5 dh by dt, delta, sorry. H, 10 plus r, still 4. And then there's the other wanted dh by dt. So this approach isn't disastrous. I have everything that I know recorded, and there's really only one unknown. There's 2 instances of it, but they're just being added together. This is going to be like terms here. I can solve here. I'm going to multiply both sides by 3, divide both sides by pi. And let me start tidying up here. Let's see, 2 times 4 times 2 times 10 divided by 5. This will be 32 dh by dt plus 16 dh by dt. So I'll get that dh by dt is going to be negative 2.5 times 3 divided by pi, and then when I remove that common factor, I'll have 32 plus 16 there. Let's see, negative 2.5 times 3 divided by bracket pi times 48, and I get the same approximation of about negative 0.05. This is a question where I'll trust the units, but do track the units through and convince yourself that it would work out. Okay, there's always more than one way to do a problem. I've suggested you could try building a chain first. I really like the approach of relating your variables first. It tends to avoid this more complicated situation. And a lot of students get confused when they say, well, I need to know what dr by dt is. I need to know its value, and that's not true. You just need to, you don't know, consider it an unknown. So you need to replace it with maybe a value or maybe an expression. If you're able to replace it with an expression of the thing that you are looking for, then you just have to deal with a little bit of algebra to collect like terms.